in this video, we will be discussing about longest strictly increasing or strictly decreasing subarray. You are given an array of integers nums. Return the length of the longest subarray of nums, which is either strictly increasing or strictly decreasing. So in the input, we are given an integer array nums. From this integer array nums, we need to find out the length of the longest subarray, which is strictly increasing or strictly decreasing. Right? That length we need to return as our answer. First of all, what is a subarray? So a subarray is nothing but when we take some continuous set of numbers from the array. Basically 1, 4, 3. This is a subarray. 1. This is a subarray. 3, 3, 2. This is a subarray. But 1, 4, 2. This is not a subarray because the numbers are not continuous in the nums array. Right? Then strictly increasing and strictly decreasing. So this array is strictly increasing, but this is not, because here the number is same. Strictly means that the number has to be different. Then this is a strictly decreasing array, but this is not a strictly decreasing array, right? So we need to find out the length of the longest strictly increasing or decreasing array. So see, what is the brute force approach that we can follow? So we want to consider the subarrays from nums, and whichever are strictly increasing or strictly decreasing, we need to find out their length, and then we can track the maximum length that we have got so far, right? So basically what we can do is that we can maintain some pointer I over here, right? And then we can start pointer j from here, that is from the next element. And then we can keep on checking the jth element with the j minus 1th element, right? When you are checking for strictly increasing, then you can check that the jth element has to be greater than the j minus 1th element, right? If it is, then you can increase the length by 1. If it is not, then you can break at this point itself and then update this length in some variable where you are keeping the track of the maximum length, right? And then again you can move your I forward, keep your j forward, and you can follow the same process, right? And then similar process you can follow for identifying the strictly decreasing. In that case, you will just check that the jth element should be smaller than the j minus 1th element, right? So this is the brute force approach, where first you would be running a for loop of I starting from 0 till n, and then you will running a for loop of j starting from I plus 1 till n, right? So here this would be running n times, this would be running n times, so the time complexity will be n square. But the constraints are very small, so it will work. We will look at the brute force approach code as well later, but now let's see how we can optimize it. So see, when we are considering the subarray, for example, earlier I was comparing these two elements. Now when I am moving next, now I am comparing these two elements, then these two, and so on, right? So basically, instead of using two loops, we can just use one loop. So what we need to identify? We need to identify the length of the increasing subarray, strictly increasing subarray, the length of the strictly decreasing subarray, and the maximum length, right? Now, a single element. A single element will always be a strictly increasing subarray and also a strictly decreasing subarray, right? So we will initialize all of these to 1, right? Because the smallest possible length is 1, right? Then what you can simply do is that you can start from this element and you can compare it with the next element. You compare these two. If these two are strictly increasing, then what you will do, you can increase this by 1 and you can initialize it again to 1. Why? Because if this is strictly increasing, then that means it is not decreasing, right? So we will update it to 1. So basically, whenever the elements are in strictly decreasing order, we will increment this by 1 and we will update this to 1. And whenever the elements are in strictly increasing order, in that case, we will increment this by 1 and we will update this to 1, right? And at each point, we will keep track of the maximum length, right? So if we see over here, we will first compare these two elements. So here 1 is less than 4. These are strictly increasing. So what we will do, we will increment this by 1 and we will update this to 1. And then in the maximum length, we will take the maximum of these and the maximum length. So it will be 2. Right? Then we will compare these two. Now here these are strictly decreasing. So in that case, we will update this to 1 and we will increment this by 1. And then we will update max length. So this will remain 2 only. Right? Then we will compare these two. Now these two elements are equal. then that means they are not strictly increasing, not strictly decreasing. So in this particular case, we will update both of these two ones, right? Because we are trying to identify a subarray, and a subarray is contain a set of numbers. So as soon as any condition is dissatisfied for any of these, we update these variables to 1, right? And then we can compare these two. So these two are strictly decreasing. So we will increment this by 1. We will update this to 1, and then we can take the max. Max will remain 2 only. And once we are done with this array, this is the maximum length that we have got, and this is our answer, right? And here you would be iterating just once in your nums array. So the time complexity will be order of n, and we won't be taking any extra space. So it will be constant, right? So now let's look at the code. So this is the brute force approach code, where we have first taken a maxi variable to keep the track of the longest subarray, the length of the longest subarray. And then we are running a for loop of I, which is starting from 0 and going till nums.size. And then we have taken a variable length and initialized it with 1. Then we are running another for loop of j, which is starting from I plus 1 and going till the end. And then here we are checking that if nums of j is greater than nums of j minus 1, that is, it is strictly increasing, then we are incrementing the length variable by 1. As soon as this condition is not satisfied, we break out of the loop, right? And outside of this loop, we are taking the maximum of maxi comma the length. Then we are again initializing the length with 1, and then we are again running a for loop of j starting from I plus 1, and we are checking for strictly decreasing, that if nums of j is less than nums of j minus 1, then increment the length, otherwise break it. And then again here we are updating the maximum variable with the maximum length, and at the end over here we are returning the maximum length. So let me run this. Now since the constraints are small, so this approach will also get accepted. So the test cases are accepted. Let's try to submit this. So now let's look at the optimized approach. So first of all, we'll take a variable maxi and initialize it to 1. Then we will take a variable for the strictly increasing subarray length and strictly decreasing subarray length. Both will be initialized to 1. Then we will run a for loop of I starting from 0 and going till nums.size minus 1, because we will be comparing the current element with the next element, and then I plus plus. Then inside this we will check that if nums of I plus 1, that is the next element, if it is greater than nums of I, then that means it is strictly increasing, right? So we will increment the increasing length by 1, and we will update the decreasing length to 1, right? Else if nums of I plus 1, if it is smaller than nums of I, then that means it is strictly decreasing. So in that case, we will increment the decreasing length by 1, and we will update the increment length to 1, right? Else, so this else will happen when nums of I plus 1 and nums of I both are equal, right? So in that case, we will update both the lengths to 1, right? And then at each point in the maxi variable, we will be taking the max of maxi comma, and then the maximum of increasing length comma the decreasing length, right? And then at the end we can return this maxi. So let's run this. So as I said, here we are iterating only once. So the time complexity over here is order of n, and we are not taking any extra space. So space complexity is constant. So the test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.